Hi everyone, and welcome to our next video in Tinkercad. In this video we're going to start looking at something we'll call text programming. Up until now you have been doing block programming in this series. We've been using things like this here to get things to work in our microcontroller. Block programming is really good to help us learn programming and start to understand some of the concepts behind it. But what you'll find is we are limited in terms of what the blocks allow us to do. And we are going to have a lot more flexibility and creativity if we can use text programming. So that's what we're going to take a look at in this program here. First of all, this is a block program, and as you can see, we are setting set pin, that's digital pin, to high. That's this pin here for the red LED circuit. Then we're going to set 13 to low, and then we're going to hold that. So this will go on, this will go off, and we'll hold that for a second. Then after that, we're going to set pin 7 to low. So we're going to turn this off, and we're going to turn this off, and then we're going to hold that for a second. And as you know, in a microcontroller, it continues to loop forever, so it will keep doing that over and over. So let's take a look at the simulation and just make sure this does what we think it's going to do. And yeah, sure enough, it flashes back and forth. So as one is on, the other one is off, just like we've built and expect in our code here. Now, what I can do, if I stop this simulation and we just move everything over here, what I can do is I can click on this here and I can go to blocks and text. And what that will do is it will convert my block program to text. Specifically, it converts it to a language called C++. So let's go ahead and do that. So there you can see what it does is here is the block program, and here's the equivalent C++ program. And here's the way this works. We have a couple of what we call functions. This void setup here is one function. This void loop is another function. And the way this works is void setup, where we have bracket, bracket, and then we have curly brace, curly brace. Anything inside here is defining what those pins are going to do on the Arduino board. We're telling pin 7 we want to be an output pin, and that's going to drive this red LED off and on. Pin 13, we want to tell it is an output pin, and we're going to drive the green LED with that. So that's the function of these lines of code. Pin mode tells the pin or port what it is going to do, so we define that in void setup. Once we've done that, we come down to void loop. And notice here that we have void loop, there's a space here, there's bracket, and then we have curly brace here, and then we have a bunch of commands in here. And really that's equivalent to this right here. So notice that we have 1, 2, 3, 4, 5, 6 lines of code here, and same here, 1, 2, 3, 4, 5, 6 lines of code. Each line of code here matches up with this block. The way void loop works is this is the code that will repeat forever in the microcontroller. So this will continue to go on and on over and over forever until we take the power off the microcontroller. Void setup only gets run once at the very beginning. After that, void loop runs over and over and over again. That's the way the code works in Arduino or microcontrollers in general. So this line here, digital write, and then bracket 7 comma high, we're telling pin 7 to go high, and that's what this is right here. Next line, we're telling digital write and bracket 13 to go low, and that's this right here. Notice at the end we have a semicolon. We must have that. That is part of the C++ language. Then we have a delay command. Well, delay is really the same as wait. It says delay brackets 1,000, and that's because C++ writes this in according to milliseconds, and 1,000 milliseconds is 1 second. Notice again, we got a semicolon after that. We have / wait for 1,000 milliseconds. Anytime you have / followed by that is a comment. So this code doesn't actually run. It's just a comment for us so that when we read our own code, we remember what that was for. Then we go to this line, digital write pin 7 low. So we're telling pin 7 to go low. We're telling pin 13 to go high using the digital write command. Then again, we are delaying for 1 second, and that's what this is here. So that's what a really small C++ program can look like, and that's the equivalent to really what we have here. What Tinkercad allows us to do is we can go here and we can say that we want to convert only to text. And let's try that. So I'm going to click here. What it says is you're sure you want to close the blocks editor. Any blocks you currently have will be lost. So once we do this and it converts to text, you're going to lose your blocks. You can't go back to blocks. So we're going to try it. We're going to go continue. And there we have this here. And now we can actually go in and edit this code if we wish. So for instance, what if I wanted to have the LEDs both off and then both on at the same time? Well, I could go in and I could edit the code here. Using the digital write command, I can say that this will go low, pin 7, pin 13 low, and then hold it for 1 second. And then we can go here and say we want this to be high and pin 13 to be high, and then hold that, and then that will repeat. So using the text editor, I can quickly change this in C++, and it allows me to do things quickly and do some other things that I can't do in blocks. Just to make sure this runs, let's go to Start Simulator. Let's just make sure this works as expected. So yeah, they're both on at the same time and they're both off at the same time. And you can see that it looks like they're on for a second and off for a second, just as expected. So that's it for this tutorial. We are going to move more from block programming to text programming, and you're going to see it's going to allow us to do certain things that we couldn't do with blocks. I hope this was informative. Thanks for watching. We'll see you next time.